Hey everybody, John Shutsky here again with Biological Systems Engineering 508, and today we're going to be talking about engineering design and performance standards. Now, let me just say a couple things about standards. Standards are not necessarily my favorite topic, but in my career, over about the last 30 to 35 years, standards have been really, really crucial. I've worked on standards, I've helped pass standards, I've been a critic of standards, or at least certain standards, and they're just really critical to the work you do. Standards can be difficult. Standards can be conceptually just complex, and I'm going to use the word thick. When I say thick, it's not only in terms of the dimension. If I print off a typical standard, it's probably going to be between five pages and maybe 105 pages. So yes, in dimensions they're thick, but they're also just difficult to plow through. The language can be complex. There's a lot of detail, but that detail carries with it a certain amount of richness that'll really be critical for the work that you do as a design engineer, not only out in the real world in real life as a practicing engineer, but also in this class and with the particular product and system that you develop. Let me remind you of a few things before I go through my 6 objectives here. First of all, this is going to be a short video, relatively speaking. I could probably talk for 2 solid hours on standards. I promise you I'm not going to do that. However, in a half hour, I really want to make sure that I cover some highlights, and I want to make sure that you follow the information and that you cover the reading information and the other things that are in the learning module. That's number 1. Number 2 is to make sure that you're constantly checking in with your advisor about engineering standards. If you're confused about that, or if your advisor perhaps is having difficulty locating standards, it's possible that I might be able to help you with that, but go to your advisor first. Number 3 is the importance of the Steenbach library. And remember back, there is that section in the Steenbach library. It's within the engineering product design research guide. Remember the steps of the design process. One of the steps in there that's covered in that research guide is engineering standards. So your library is really critical, as are your librarians. I've already talked a lot about the importance of librarians. The librarians can help you get physical copies of standards, and I think a lot of you are probably going to be needing to talk, whether it's Dave Bloom or Ann Glorioso or one of the other standards librarians. They can help you to get the stuff that you need, to get the information that you need. But again, pay attention to the guidance from your advisor. So what is a standard? What purposes do standards serve? Why are we looking at standards now, so early in the design process? Who develops standards? What do standards look like? And then also, what is the connection? It's a really important connection between engineering standards and laws, rules, and regulations. I do want to just mention I've got a lot of graphics, a lot of pictures in this presentation, and those come under a paid license from Shutterstock.com. So the first question then is, what is a standard? A standard, according to the American Society of Mechanical Engineers, is a set of technical definitions and guidelines, if you will, kind of a how-to instruction manual for designers, manufacturers, and sometimes even for users. Again, if you go to the Steenbach definition and some of the materials that will be linked in the learning module, a standard is a prescribed set of rules, conditions, or requirements concerning definition of terms, or the classification of components, or the classification and specification of materials, performance, or operations. And by the way, there's a lot there. There are a lot of standards that deal with materials, performance, or operations, or the delineation of procedures, or the measurement of quantity and or quality in describing materials, products, systems, and services or practices. So they're basically guides, but they're more important than just some suggestions and some how-to things. They have power, and that power in part is vested in the way in which standards get developed as they work their way through the development process. So a standard, when I say developed, a standard is generally developed and then published as a document, and they're usually published by engineering professional organizations. So remember, that early definition is from ASME, the American Society of Mechanical Engineers. ASABE also publishes standards. There is also a group that represents the United States. If a standard has applicability across different industries and across different disciplines, in a lot of cases, they may start as an ASABE standard, but they may eventually become an ANSI standard, which is the American National Standards Institute. And if you're developing and designing products for an international market, you may want to consider the International Standards Organization. Again, if I'm going to be selling tractors or some other machine or component to Europe or to Africa or a country in Asia, I want to make sure that I'm thinking about the appropriate ISO standards. I actually have an example here. ISO standard, there's a brand new ISO standard coming out here in 2021 pertaining to the design of ventilators. So ventilators are really crucial during the pandemic. If a person is having difficulty breathing, a ventilator essentially, when we talk about being intubated, that's having a tube put down into our mouth, down into our breathing system, toward the direction of our lungs, and ultimately a machine that breathes for us. So if you think about that, a really complex machine, a machine that involves the need for a consensus process. So all of these standards, we oftentimes think of them as consensus standards, and that means that there's all kinds of different people involved in their development. So they obviously include engineers, they include other industry experts, they may include university researchers to make sure that we have the appropriate types of information and data that's going into the design or the development of a standard. We may also have legal people and regulatory experts, as well as customers and product users. In the case of this ventilator standard, it's obviously an important piece of highly engineered equipment. It probably includes mechanical components, electrical and electronic components. But we also need to be thinking about biomedical engineering. We need to have people who have expertise in medicine, in the science connected to our lungs and our heart, so like pulmonologists, and then probably even users, including maybe past patients, people that have been on a ventilator before, maybe nurses and other people, respiratory therapists. So the idea here is that these standards are developed through a consensus process until a consensus is fully developed and understood and agreed upon. And in some cases, these standards can take years or even decades to pass the standard, to put it into practice. We actually refer to that as promulgated. A standard is promulgated, which means it gets approved, passed, and then published and put into practice. There is some chance that there are some of you in this class that will actually get involved in this process of developing and promulgating standards. But even if you're not involved in that process, there's a really great chance. In fact, almost all of you that are practicing as engineers, you will be using these standards. You'll be putting the standards into action. You'll be attending to, following, and complying with these standards as part of your work as a practicing engineer. So question is like, what purpose do standards serve? There are lots. These are just a few. Number one, they provide for a common terminology. I've got the picture here of all the nuts and the hex head bolts. These are, a really common, probably the most common type of fastener that you might use if you are assembling some type of product or machine. And you want to make sure that if I go to the hardware store, if I go to Ace Hardware and I'm looking at a 5/8 bolt and I need a number 5 grade bolt and I'm going to be using it for a particular product, I want to make sure that what I buy has a specific terminology. And I want to make sure that that's designed according to specifications so that I've got the required amount of strength and that my wrench and that my toolbox, that the tools that I have in my toolbox will work with these fasteners. So that's all standardized. That's an example of a product that has been standardized for decades, actually for probably more than a century. This standardization process, when we look at things like bolts and nuts and parts, actually helps us to reduce the cost of products by providing for a lot of interchangeability and compatibility. A lot of products use things like fasteners and other components that have in fact been standardized. Here's actually an example of a product that has not been standardized, the lightning connection that I use on my iPhone. There are some companies that decide, yeah, instead of using a common or a standardized product, we're going to develop our own proprietary, in this case, the lightning plug used for my iPhone. So companies can choose to use non-standardized products, and in some cases, they may fetch a premium price for that product in the marketplace, but it does provide sometimes for some issues of compatibility. We also want to make sure, as I talked about with nuts and bolts, if I buy a bolt, I want to make sure that a grade 5 bolt of a certain dimension has a certain tensile strength and other types of requirements to handle the forces that we're going to be putting on that particular fastener. And we also talk about how that product might actually be tested before it gets put out into the market. Standards can also be used to improve safety. I'll come back and talk about a couple of examples of that in a minute. And they can also be used as a foundation for regulations. They're not regulations themselves, but they are often used as the sort of background, the foundation, if you will, for the good development of a regulation that has a strong science and a strong consensus that stands behind that regulation. Let me just give you this quick example here. I love these. These are smart Wi-Fi light bulbs. I bought these at home, not at home, at Menards not that long ago. I'm not going to turn around and point to them, but I do have them in the fixture that's up above me. These smart light bulbs are fully connected to my Wi-Fi. I can control, basically I can turn my lights on and off with my phone. I can dim my lights. I can go from kind of a warm colored, kind of a goldish brownish tone that makes my room feel warm and comfy, or I can go with a really bright, high intensity white or blue light. And I can also, just through my phone, I can go onto this LED bulb with a smartphone technology or with a smart Wi-Fi technology, and I can dial in literally on any color under the rainbow, and I can dim any color under the rainbow. So really cool. But there are a ton of standards behind this product. For example, this product, this light bulb that I bought, like a lot of light bulbs that are LEDs now, are what we call Energy Star compliant. That means that they have certain parameters that allow them to conserve energy and to be certified as such. In order to do that, we need to be meeting certain standards for these light bulbs or the light bulb company to put on that Energy Star stamp. So that would be an example of standards. Another one is that this light bulb claims that it has an 800 lumen light output. So that's basically how bright the light is. Now, you can't just throw 800 lumens on the package. There is a standard for testing the light output of the bulb. I'm not a lighting expert, so I don't know exactly what that procedure looks like, but it's very detailed and it's very specific. And you better bet if you're putting a bulb like this on the market, you need to know how to test it to be able to label it with an 800 lumen output. And you also want to know that up front as you're designing the bulb to make sure you're compliant even before you do the testing. Another thing is that this light bulb says that it is suitable for enclosed fixtures. So when I put this light bulb in, it does generate some heat, even though it's very energy efficient at the base. And so you want to make sure that if I put it in and I put a shade over it and there's an enclosure, that heat buildup isn't big enough to start a fire. So again, there are standards that dictate how you test and are able to claim suitable for enclosed fixtures. We also know that this light bulb, from the label and from my slide here, that it has a 22.8 year life. Now you can rest assured they didn't take 22.8 years to develop this and put it in a fixture and turn it on and wait till the light bulb turned out. There are standard methods for testing the lifetime or the lifespan of a bulb that require a lot of testing, and it's probably a lot more than we could go into in this class, but you get the picture. There are instructions, there's formulas, there's protocols, there's procedures for how to do this according to standards. We also know it's not just a light bulb, right? If I'm going to control it with my phone and I'm going to control it through Wi-Fi, I need to make sure that I am Wi-Fi compliant. In this case, Wi-Fi that puts out a 2.4 gigahertz signal That's according to a standard. And the idea here is that any device that is 2.4 gigahertz or 5 gigahertz compliant can connect with my router. And in that case, that includes my light bulbs, but it also includes my phone and my laptop computer and all of the devices I have in the house. One other quick example, this one's been around for a lot longer. The base of this light bulb, this goes into a standard light socket. Again, a standardized, measured, so that I can go out and buy a General Electric bulb or a Sylvania bulb, or in this case, Fight Electric, and I can be sure that everything is going to match up and be compatible because standards exist. Some examples from our different emphasis areas in BSE. And I also talked about how standards can be used to improve safety. So this is kind of a double example. So machinery systems and safety. Farming, very dangerous. The biggest killer on farms, the biggest cause of fatal farming accidents or injuries is when tractors roll over. And so we have things on tractors just like we do on certain vehicles like pickup trucks and Jeeps and off-road utility vehicles. We have things called rollover protective structures or ROPS. If you think about it though, this ROPS, if you are being protected by the ROPS, if that tractor rolls over either sideways or backwards, you don't want it to crush you. You don't want a safety device to actually cause a bigger hazard. So there are testing procedures that dictate the forces that a rollover protective structure needs to withstand in the event of a tractor rollover. And you can see it's very specific. You design the ROPS or the rollover protective structure, you install it on a tractor according to the standards and according to the specifications. And then you put it in a building and you have a really large mass, a really large weight that's suspended from the ceiling at a certain angle. And it's basically a pendulum, and that pendulum comes down and it smacks the cab, or that smacks the ROPS, the rollover protective structure, and that structure can only deflect by a certain amount in order to meet the performance requirements of the standard. And there's lots of examples like this of the testing requirements to ensure that something works appropriately and works according to its designed function. In the environment natural resources area, I've had people who have said like, standards is more for the machine systems people. Actually, we have a ton of natural resource and environment standards. And for those of you working in wetlands, in the stormwater retention system, even the composting sites, there are very detailed standards that you're going to want to pay attention to. This is one that I find to be particularly interesting, published by the NRCS, the Natural Resources Conservation Service, which is an agency of USDA. And this is a standard for the design of a snake hibernaculum. I had to think about that for a second. A snake habitat, if you will, or a snake, an area where snakes like to hang out. And if you see here on the slide, lack of adequate hibernaculum for snakes is a limiting factor in snake population. So NRCS, among other things, they provide incentives to landowners and farmers to do certain conservation practices. And one of them is they'll say like, hey, we'll actually put some money in and help you build habitat for snakes. However, if you're going to take our money and do that, you've got to do it according to our standards. And so we have a very detailed standard here for building snake habitat. How about the food area? So this is machinery systems, natural resources, environment. How about food? Yeah, in food, definitely. There are probably as many standards in the food industry as is in any other industry. Here's one that's kind of fun. If I'm going to put a new peanut butter product out onto the market, and if I'm going to call it peanut butter, there are very specific standardized requirements. The one at the top is if I'm going to call it chunky peanut butter. I've always wondered about this. What differentiates like smooth or medium texture peanut butter from chunky? If it is chunky or crunchy peanut butter, both of those terms are acceptable. There needs to be a substantial amount of peanut butter particles or peanut particles larger than 1/16 of an inch in any one dimension. So there are standards that dictate the chunkiness of your peanut butter. There are also standards that are put out by the National Institute for Standards and Technology that dictate how you test peanut butter. how you determine the fat content, the carb content, the protein, the fiber, and some of the different components of a peanut butter product. So that's a lot of information to throw at you. Why are we looking at that? Why are we looking at standards this early in the process? Number one, it will help you understand the complexities of designing your product and the types of guideposts and expectations that your product is going to have to meet when you develop your prototype and when you do your testing. It might also provide you with some suggestions on how you test your prototype once you've got a prototype ready. It also helps you to understand the relationship between components in some cases. And I use my example here of my LED light bulb with all these colors, and I can control it through my Wi-Fi and my smartphone. There's a lot of things to be understood there with the specifications and the standards connected to Wi-Fi and light output and the actual, again, the physical design of my light bulb, the safety of my light bulb. And so understanding those involves and requires a detailed review of the standards connected to that product. And then the last thing I will say, and I'm going to come back to this in just a moment, knowing standards and understanding and complying with standards is absolutely essential in your role as an engineer if you want to protect yourself from liability and malpractice. And again, I'll come back and talk about that here in just a minute, as in this slide right now. So the question then is, what's the connection between engineering standards and laws and rules and regulations? Number one is oftentimes people get standards and regulations confused. By themselves, standards, especially consensus standards, are generally not regulations and laws. However, they oftentimes get embedded into laws because, well, they represent the best practice. They represent the best thinking of a variety of different people, of a variety of different individuals, and then legal people, lawmakers, those people who work in Congress or regulatory agencies, they embed these standards or the references to these standards in their laws. So just a really quick example. We have a set of consensus standards called the National Electric Code. So if I'm going to go out and wire a shed, or I'm going to build a new house, I think a lot of you who have ever been involved in building a structure, doing construction work, you have to follow the National Electric Code. And the reason for that is because state and local agencies who regulate buildings and go out and do building inspections, when they're doing their regulatory compliance stuff, they're using the National Electric Code as kind of their foundation. You know, there's nothing better out there, so they rely heavily on that National Electric Code as the body of knowledge for their regulatory enforcement activity. Just another quick example that I've been very involved with, ASABE has a standard called, it's the S297 standard, or sorry, 279 standard, that involves the lighting and marking of agricultural machinery and equipment that's used out on public highways. Now, by itself, it's just a consensus standard. However, the federal government about 5 or 6 years ago passed a law that said now, according to federal law, any new piece of equipment that comes off of an assembly line is being operated on a public highway must comply with the details in ASABE 279. So they have incorporated, through reference, they have incorporated that standard into a federal legal requirement that's enforceable both at the state and the federal level. Standards also, this is a little subtle thing, and I'm going to talk more about this when we talk about liability, just briefly when I talk about safety here in a few weeks. But standards oftentimes form the basis for civil lawsuits if a person sues another person because they've been hurt or injured or because a building burns down. So let me give you a quick example. If I build a new building and I hire an electrician, and that electrician comes in and does a poor job of wiring that building and did not understand the National Electric Code, and they were not a certified electrician who would be expected to follow the National Electric Code, and my building catches on fire because of an electrical malfunction, somebody is going to be going to the courtroom and then explaining, like, okay, even though it was not legally required as a consensus standard, why were you not following what the industry accepts as the best information in this area? Or if I'm designing a piece of equipment like I talked about, and I don't have a rollover protective structure that deflects at the right amount, the minimal amount when smacked or when tested in a lab, and somebody is killed and there's a tractor overturn and the ROPS crushes that person, and I haven't paid attention to that rollover protective structure testing standard, I'm going to get sued and I'm going to be found negligent. And the chances are I'm going to have to pay large penalties as a result of being negligent. Negligence, by the way, is the failure to follow or consider a standard, which again is oftentimes used as the basis for negligence. And among other criteria for proving negligence is failing to act as a prudent engineer might or would act. So prudent engineers, engineers that are doing their work, that are protecting themselves and their companies and their customers from harm, are going to pay attention to, they're going to understand, and they're going to follow the details that are found in engineering standards. So some final thoughts. Standards are complex. As I talked about, they're thick, they're deep, they're complex, they're difficult to slog through, but they are critical for your design. And they're vital for what I would call our project or product design specifications. We're going to get at that in about a week or two. I often will refer to those as PDS, which again is product or project design specifications. Standards are a really key part of your PDS, okay? And then finally, again, just as a reminder, this is only an introduction. I really encourage you to pay attention and actually attend to the rest of the information that's contained in this module. Check in with your advisor, check in with the Steenbach librarians. I think that you'll find standards to be helpful for your design. And I look forward when you begin to look and detail and actually analyze and interpret the importance of your standards for your design. I'll be looking at that, and I'll be excited to see what you came up with and which standards you are paying attention to.